today's video I will start a new chapter, that is solid state. Already videos made by other teacher I have sent, but just I want to send self made video because what type of questions are asked in the examination I will discuss with that also. Now what is solid state? Now the constituent particles in solid states have fixed position and they can oscillate about their mean positions. Therefore, they are rigid and that is why it is called solid in nature. In the other two states, the particles are free to move. In gases, it is extremely free to move. Now, in crystalline solid, the constituent particles are arranged in regular pattern. Means if the particles are arranged in cubical form, so throughout the crystal they will be arranged in cubic form. Now, what are the general characteristics of solid state? At very low temperature, the thermal energy is low and intermolecular forces bring them close that they cling to one another and occupy fixed position and can oscillate about their mean position and exist in solid state. Now, what are the characteristics of solid state? This you are studying from the lower classes only. Number 1, there has definite mass, volume and shape. Intermolecular distance are very short. Intermolecular forces are strong. Their constituent particles like atoms, molecules or ions have fixed position and can oscillate about their mean position. They are incompressible and rigid. You can take the example of ice. Now, the crystalline or the solids, they are of two types, now amorphous and crystalline solids. So, types of solids we have to study. Number 1, that is crystalline solid. Crystalline solid has definite geometrical shape, that is the arrangement of the particle is ordered. For example, I have drawn a structure of cube. This is the structure of NaCl. This is a single unit. Now, this unit is repeated 3-dimensionally. So, structure throughout the crystal you will find same, then it is crystalline solid. Whereas, in amorphous solid, they have irregular amorphous solids have irregular shape, that is their arrangement of particles are not ordered. Crystalline substance have long range order. It means that there is a regular pattern of arrangement of particles which repeats itself throughout the crystal. चाहे आप ऊपर नीचे अगल बगल देखें, स्ट्रक्चर आपको सेम दिखाई देता है तो वो क्रिस्टलाइन सब्सटेंस कहलाते हैं. Now, amorphous solids have short range order, that is the arrangement of the solid is same for small distance and then it changes. You can take the example, that is quartz glass. Now, quartz glass is amorphous whereas quartz is crystalline. So, do not get confused, sometimes examples are asked. So, quartz is crystalline whereas quartz glass is amorphous. Now, crystalline solids have sharp melting point, means if any substance is going to melt at 62 degrees centigrade, then it will melt at 62 degrees. Whereas, amorphous substance, they have large range of melting point, means at least 4 to 5 degree. If they start melting at suppose 52 degree, then it will go finally melt on 55 or 56 degree. So, they are amorphous solids. Now, crystalline solids are anisotropic in nature. It means that there are some physical properties like electrical resistance, refractive index, they have different value in different direction in the same crystal, whereas ice, that is amorphous solids, have, or they are isotropic in nature. It means that they have same value in along any direction. Next point is crystalline solids are true solids, whereas amorphous solids are pseudo solids, or they are also called as super cooled liquids. Pseudo solids, they are called as super cooled liquids. Now there are some glass objects from ancient civilization, they found or they turned milky due to crystallization. The glass panes fixed to windows or doors of old buildings are thicker at the bottom than at the top, because the glass flows down very slowly and makes the bottom portion slightly thicker. So these two properties you can see in the old buildings, जो किले वगैरह बने हुए हैं वहाँ जाके आप observe कर सकते हैं. Next point is that crystalline solids, when they are cut with a sharp object, they split up into two clean pieces, with whereas amorphous substance they do not split up with the clean surface, they split up with the irregular surface. Now amorphous silicon is one of the best photovoltaic material conversion for conversion of sunlight into electricity. Now next is classification of crystalline solids. They are of 3-4 types. Number one is molecular solids. Molecular solids are, the constituent particles are molecules, and they are of 3 types. Number one is non-polar molecular solids. Constituent particles are atoms, for example argon, helium, or molecules having non-polar bonds between them like hydrogen, chlorine, iodine. The force of attraction among them are weak dispersion forces or London forces. The properties of the non-polar molecules are, that is, they are soft, non-conductor of electricity, have low melting point, and are liquid or gases at room temperature. The second type of crystalline solid is, that is polar molecules. The polar molecules are formed by polar covalent bond, for example HCl and SO2. The force of attraction found between them are strong dipole-dipole interaction. The properties of these solids are, that is, they are soft, they are not conductor of electricity, melting point higher than non-polar molecules. Third type is hydrogen bonded molecular solids. These molecules contains polar covalent bonds between hydrogen and the atoms like fluorine, oxygen and nitrogen. This already you have studied in hydrogen bonding in class 11. So hydrogen bonding is formed in water, ammonia, HF, and due to the hydrogen bonding the water molecule exists in solid state, that is ice. The properties of these solids are, they are non-conductor of electricity, volatile liquid or soft solids under room temperature and pressure. Next is ionic solids. Now ionic solids, they are made up of ions. Ionic solids, they are made up of ions and they are formed by three-dimensional arrangement of cations and anions. Now the force of attraction among them is strong electrostatic force of attraction. They are hard, properties of these solids, they are hard, brittle, have high melting and boiling point. Now since their ions are not free to move, so they are bad conductor of electricity in solid state, but in molten state or in aqueous state the ions are free to move, so they becomes good conductor of electricity. Next is metallic solids. Metallic solids, that is they are formed in metals. Now metals, all of you know, are orderly collection of positive ions surrounded by and held by a sea of free electrons. These electrons are mobile and evenly spread in the crystal. The force of attraction is metallic forces. Now the metallic forces are the force of attraction between the nucleus and the mobile electron, nucleus of one atom of the metal to the mobile electron of the other. The properties, all the properties of metal they will show, like high electrical and thermal conductivity due to mobile electrons. Number 2, they show metallic luster, they have color, they are malleable, ductile. Next is covalent or network solids. Now crystalline solids of non-metals, due to the formation of covalent bond between adjacent atoms throughout the crystal, they form giant molecules. Covalent bonds are directional bonds. Atoms are held strongly at their position. Properties: hard and brittle, extremely high melting point and boiling point. We can take the example of, that is diamond or graphite. Now diamond or silicon carbide, they are bad conductor of heat and electricity because the one atom of the carbon is linked with 4 carbon atom and no free electron is present, therefore it is a bad conductor of electricity. It has tetrahedral structure. Hardest substance known, diamond is the hardest substance known. Now the second allotrope of carbon is graphite. It is soft, good conductor of electricity due to its structure. You can see here, that is one atom of carbon is linked with 3 carbon. The fourth valence of the carbon remains free and that is attached by weak van der Waals forces of attraction with the other layer. It has hexagonal structure, so it has layered structure, and between the two layers the valence carbon atom, which is free, he gets bonded with weak van der Waals forces of attraction. So due to this weak van der Waals forces of attraction, one layer can slide over the other and makes the graphite that a soft solid and good solid lubricant. So these all points already we have studied in lower classes also, but since in this chapter we have to study. Next is the main point of the chapter comes now, that is crystal, lattice and unit cell. Now crystal lattice and unit cell, it is the regular three-dimensional arrangement of points in space is called a crystal lattice. Now points means atoms, molecules or ions, anything it may be. So total possible crystals present are 14 and they are called as Brebes lattice. The characteristic of crystal lattice is that each point in a lattice is known as lattice point. You can see here these points are called lattice points. Now I have drawn one cube with the red. So this total it is a structure of cube, and this cube when expanded three dimensionally, top, bottom, front, backward, then you will get a structure of a crystal lattice, and this single is known as unit cell. So here the main point is that each point in a crystal lattice is called lattice point, and each point represents one constant particle which may be atom or molecule. The lattice points are joined by straight lines to bring out the geometry of the lattice. I have drawn the structure of NaCl. So NaCl has cubical structure. Now the unit cell is the smallest portion of the crystal lattice, which when repeated in different direction they generate the entire lattice. Now characteristics of unit cells, when you take the example of a room, you will see that at the corners are assumed as edges. So you can see that total 4 corners are there. So 4 edges are present, and the 2 edges you can say consider, that is 4 at the top, 4 at the bottom. So total I think 12 edges are there. Yeah? And these edges are perpendicular to each other, but in some of the crystal in the room, if you consider it is perpendicular, but in crystals it may or it may not be perpendicular, mutually perpendicular to each other. You can take the example of a room and you look around, then the corners will give you the edges. So 12 edges are there. Now the angle between the edges. So there are 3 angles are there: alpha, beta and gamma. Alpha angle is between, so we have named here, that is, this is side B, edge side B, this is side A and this is side C. The angle between C and B we denote by alpha, between A and B gamma, and between A and C beta. So these are, so total 6 parameters, 3 that is edges A, B, C, and 3 angles, that is alpha, beta and gamma. Now types of unit cells. Broadly 2 types of unit cells are there. Number 1 is primitive unit cell. When the constituent particles are present only at the corner of the unit cell, then it is known as primitive unit cell. And you have drawn one, once again I will draw, because this diagram you will draw. So you can see here total it is a cube. This is the simplest. Only 8 atoms are present at the corners. So primitive unit cells with the constituent particles which are present only at the corner of the unit cell. So total 8 atoms are present at the corner. Now second type is, that is centered unit cell. Now centered unit cell, along with corners, constituent particles are also present at other positions. They are of 3 types. Number 1, body centered. Along with the corners, constituent particles are also present in the center of the body crystal. You can take the example. This is a small cube. Now you can see it is at the corners. So 8 atoms are present at the corners and 1 is present in the middle. So this is called as body centered and they are joined like this. The next is face centered. Along with the corner, the constituent particles are present at the center of each face. So now you can see, you can take the example of the room, that is 4 walls are there and 1 floor and 1 top. So total 6 faces are there and at each face in the middle there is that is crystal point, the atoms are present. So this is the top. So you can example room का एकदम एग्जाम्पल लीजिए, आपको क्लियर हो जाएगा. ये छत के ऊपर है, ये ज़मीन पे है और ये 4 दीवारें हैं. तो 6 तो ये हो गए और 6 के अलावा 8 जो है कॉर्नर्स के ऊपर. And the last, that is end centered, along with corners, the constituent particles are also present only at the end of the 2 faces. क्रिस्टल बहुत लंबा है लेकिन किनारे किनारे वाले पे ही प्रेजेंट है. कॉर्नर के साथ साथ जो है सिर्फ एंड के 2 फेसेस में प्रेजेंट रहता है, उसे एंड सेंटर्ड यूनिट सेल कहते हैं. सो इन टुडेज सेशन वी हैव स्टडीड अबाउट व्हाट इज सॉलिड स्टेट, what are the characteristics of solid states, what are the types of that is solid crystal. They are 2 type, amorphous and crystalline, and that is types of solid. Then what is crystal lattice, unit cell, types of unit cells.